Humanity is on the verge of one of the most thrilling achievements in space exploration, bringing a piece of another planet back to Earth. NASA's Mars Sample Return (MSR) mission holds the potential to answer fundamental questions about our universe while pushing us into a new era of space exploration. Beyond scientific discoveries, space exploration fuels innovation, creates high-paying jobs, and inspires future generations. The United States has a long history of leading the way in space, and to maintain that pioneering spirit, the MSR mission must be completed more quickly and affordably than current projections suggest. Exploration is at the heart of Rocket Lab. The drive to push boundaries, tackle complex challenges, and develop innovative capabilities has always been a guiding principle. With experience spanning multiple planetary missions, including journeys to the Moon and an upcoming private mission to Venus, Rocket Lab has played a key role in advancing interplanetary exploration. The company's solar cells power a majority of deep space missions that don't rely on radioisotope thermoelectric generators. And last year, Rocket Lab successfully delivered 2 spacecraft for NASA's Mars-bound mission. From launch vehicles to deep space exploration, the company remains committed to expanding access to space in ways that ultimately improve life on Earth. This commitment to planetary science has led to a strong interest in the Mars Sample Return mission. MSR is a top priority for the scientific community, representing a bold step toward uncovering the origins of the universe and paving the way for human exploration of Mars. While the ambition to return Martian samples has existed since the 1970s, escalating costs and extended delays have made the mission seem perpetually out of reach. Yet, the determination to explore and discover ensures that this goal remains within grasp. NASA acknowledged last summer that the existing MSR design had become too expensive, with costs projected to reach $11 billion and a return timeline extending to 2040. In response, the agency launched an independent review and industry studies to explore alternative approaches. By December, NASA had concluded its review, announcing the need for an additional year and $300 million to continue evaluating options. The 2 proposed approaches include a NASA-led architecture that closely resembles the previously canceled plan, or a commercially integrated option relying on costly heavy-lift vehicles with long lead times. Even with these alternatives, sample return could still be delayed until 2039, with costs reaching $7.7 billion. To put this mission back on track, decisive action is required. The best course forward is to fund commercial MSR concepts immediately, enabling the mission to be completed faster and at significantly lower costs. Rocket Lab is uniquely positioned to deliver on this vision, with a proposed approach that could return samples as early as 2031 for under $4 billion, operating under a firm fixed-price contract to ensure cost efficiency and timely execution. Rocket Lab's plan relies on a 3-launch system, including a Mars Telecommunications Orbiter, a Sample Return Lander, and an Earth Return Orbiter, ERO. Unlike the baseline mission concepts, this approach avoids complex in-space refueling and eliminates the need for human-operated retrieval missions. The architecture integrates multiple technical advantages to simplify execution, including utilizing commercially available launch options to reduce costs and logistical complexity, employing storable chemical propulsion for the Mars Ascent Vehicle, EMAV, and ERO, leveraging the company's flight-proven Electron Rutherford engines, incorporating proven Mars entry aeroshells and supersonic parachutes for reliability, using heritage propulsion designs for the lander and lunar-derived landing guidance systems to ensure precision, simplifying robotic systems for sample transfer between the Perseverance rover and MAV, deploying a single-stage MAV, avoiding multi-stage solid propulsion complexities, relying on in-house solar power solutions instead of nuclear-based systems, partnering with NASA on key technologies such as thermal protection, entry, descent, landing, and contamination control. integrating deep space communication and navigation expertise in collaboration with Johns Hopkins Applied Physics Laboratory. Using heritage technologies for sample containment and return, leveraging established proximity operations and docking capabilities. Implementing a direct entry impactor system for Earth return. Eliminating the need for parachutes. When the space shuttle was retired, NASA didn't embark on a costly, government-led development program to regain human spaceflight capabilities. Instead, the agency turned to the private sector, leveraging commercial innovation to deliver results. A similar approach should be taken for science missions, ensuring that taxpayer dollars are spent efficiently while advancing exploration. Returning samples from Mars will be a historic achievement, but it is just the beginning. The technologies developed through MSR will serve as essential building blocks for the next great milestone, sending humans to Mars. To make this mission a reality, a bold new strategy is required. Now is the time to embrace a fresh approach and push forward with determination. Did you know that over 95% of our viewers aren't subscribed to the channel? We totally get it. Life gets busy, and sometimes it's easy to forget. But here's the thing. Subscribing is completely free, and it really helps us keep creating the content you enjoy. So, why not hit that subscribe button and join our community? It only takes a second, but it makes a world of difference to us. Thank you for your support.